Welcome to Kanerika's podcast, The Digital Shift.
It is great to be here.
So I want you to picture something for a second. Imagine you're a developer.
Okay.
It's late on a Friday afternoon. You've got this failing test suite that is completely holding up a massive deployment.
Oh, every developer's worst nightmare.
Right. Your weekend is basically about to vanish, but instead of digging through thousands of lines of code for hours, you just sit back and watch.
Just watch.
Yeah. You watch an AI system automatically dive into the repository, isolate the bug, explain exactly what went wrong in plain English, and then write and commit the patch.
All on its own.
All on its own. And the craziest part, the entire process from start to finish happens in under 60 seconds.
What's fascinating here is that we have crossed a massive threshold in software engineering. I mean, these are no longer just advanced autocomplete tools, right?
Right, the ones that just sit in your editor and quietly suggest the next line.
Exactly. They've evolved into fully autonomous coding agents. They can read sprawling repositories, plan complex execution sequences, and actually execute tasks from start to finish without you having to hold their hand.
That is a huge claim. And if we are truly moving from autocomplete to autonomous execution, we need to look at how that actually works in practice. So that's the mission for our conversation today.
Definitely.
We are exploring some incredible content detailing the early 2026 landscape of these AI coding agents. Specifically, we're looking at the heavyweight showdown between OpenAI's GPT 5.3 Codex and Anthropic's Claude Code running on their Opus and Sonnet 4.6 models.
A really interesting matchup.
Oh, absolutely. We're going to figure out how these tools work, where they shine, and how you can actually integrate them into your daily workflow.
And we really need to understand this shift because the adoption numbers are just staggering.
Yeah.
According to the data we're analyzing today, over 70% of developers are now using AI assistants for coding tasks.
70%, that's huge.
It is. Furthermore, GitHub research indicates that developers are completing certain tasks up to 55% faster with this kind of AI support.
55%.
Yeah. That kind of efficiency gain isn't just a nice to have, it completely reshapes the economics of how software is built.
Okay, let's unpack this. Because while they might look similar on the surface, both take natural language prompts, both write code autonomously, both hook into version control.
Right.
How they actually operate under the hood couldn't be more different. Let's start with architecture and data residency. Basically, when you hand off a task, where does your code actually live while the AI is working on it?
This is a fundamental divergence between the two systems. And honestly, it dictates how you can even use them. GPT Codex operates as a cloud-based agent.
Okay.
When you give it a task, it works through it autonomously inside a sandbox environment up in the cloud. It plans sequences, manages dependencies, coordinates changes across multiple files, completely off your machine.
So it's essentially taking all the heavy lifting away from my local computer. But Claude Code takes the exact opposite approach, right?
Precisely. Claude Code executes locally. It sits right inside your local terminal. Your code stays on your actual machine.
Wow, okay.
Yeah, it reads your local file system, runs commands in your actual terminal environment, and uses your local Git setup. The only thing that travels across the internet to Anthropic's API is the text prompt you typed and the specific snippets of code it needs to analyze in that exact moment.
That feels like a massive distinction for corporate security.
It is.
Because if I'm an IT director, sending proprietary, unreleased source code to a cloud container, even a highly secure one,
Might be a complete non-starter.
Exactly.
The implications of that local execution model are massive, especially for the enterprise. If you're working in a highly regulated industry, finance, defense, healthcare, you deal with incredibly strict data residency requirements.
Right, data can't leave certain boundaries.
Exactly. Claude Code's local approach is an elegant solution for air-gapped environments. And just to clarify, an air-gapped system is one physically or logically isolated from unsecured networks, like the public internet.
So it's locked down.
Locked down tight. Because Claude processes locally, nothing is pushed to a centralized external cloud container, making it much easier to clear through compliance boards.
That makes total sense for security paranoid teams. But what about the setup? If Claude is deeply integrated into my local machine, that sounds like it might take some serious work to get running.
It can.
The material suggests Codex actually has a major advantage when it comes to just plugging it in and going.
It does. Codex trades that ultimate isolated security for sheer speed and consistency of deployment. It relies on standard agents.md files for its configuration.
Agents.md.
Yeah. Think of an agents.md file as a simple text document that lives in your project folder. It gives the AI a very specific set of instructions on how to behave in that specific code base.
Oh, I see.
It's an open standard that tens of thousands of open source projects already use.
So if a team is already using existing AI coding assistants like Cursor or Aider, they can just drop their existing instruction file straight into Codex without having to rewrite their entire workflow.
Exactly. Plus, because Codex runs in the cloud, it handles long-running tasks autonomously without tying up your local machine's compute power. If it needs to run heavy compilations or massive automated tests, your laptop's fan isn't going to sound like a jet engine.
Very true. But since Claude is sitting right there on your local machine, that brings up a massive question about its sheer processing power compared to Codex's cloud setup.
Right.
Let's talk about the specs. We have to look at the memory these models have, which in the AI world is called the context window.
This is where we see another stark contrast. A context window is essentially the model's short-term memory. It dictates how much text, or in this case, how much code, it can hold in its brain at one single time. Opus 4.6 comes with a standard 200,000 token context window, but they also have a massive 1 million token context window available in beta.
1 million tokens.
Yeah. GPT 5.3 Codex, on the other hand, operates with up to 192,000 tokens.
1 million tokens versus just under 200,000. That sounds like a huge discrepancy on a spec sheet. But what does 1 million tokens actually mean for you as a developer in the real world?
Think about trying to navigate a massive legacy enterprise code base.
Oh, boy.
Right. We're talking undocumented business logic written by someone who left the company 5 years ago, tangled dependencies, code spanning dozens, maybe hundreds of interconnected files.
A nightmare.
Exactly. A larger context window is like having an incredibly massive desk. The AI can lay out all those files, all that architecture, and look at it all at once. Claude Code can build familiarity across your entire project across sessions, rather than having to start cold or lose track of how a change in a user interface module affects a database query 3 layers deep.
Here's where it gets really interesting, though. Having a giant desk is great, but how efficiently do these models actually work at that desk?
That is the key question.
The material highlights a really revealing benchmark. There was a Figma cloning task run by a group called Composio to test token efficiency. And just to set the stage, cloning Figma is not a small task.
Not at all. Figma is a highly complex, collaborative design application.
Exactly. Replicating that means handling intense front-end graphics and complex back-end syncing logic. To complete this exact same task, Codex used only about 1.5 million tokens.
Okay.
Claude Code used 6.2 million tokens.
That is a staggering difference in efficiency. Codex is using essentially 2 to 4 times fewer tokens per task.
Okay.
And while Codex does have a slightly higher per token, costs $6 per million input tokens compared to Opus at $5, that efficiency difference compounds rapidly.
Right, because if I'm an engineering manager scaling these tools across a team of 50 or 100 developers, the cost gap between 1.5 million tokens and 6.2 million tokens for routine daily tasks becomes very meaningful to the bottom line.
Highly meaningful.
It's the difference between a minor software expense and a major budget line item.
Absolutely. And when you look at how they actually score on raw performance, the race is incredibly tight. We have to look at the SWE-Bench verified leaderboard.
Right, SWE-Bench.
It's a highly respected industry benchmark that literally scrapes real, complex bugs that human developers struggled with on GitHub and asks the AI to solve them blind. On this benchmark, Opus 4.6 scores 80.8%. Codex 5.3 is right on its heels at approximately 80%. They're virtually neck and neck.
But the data suggests that when you look at specialized benchmarks, you start to see their distinct personalities.
Yes.
Claude slightly leads in SWE-Bench Pro, which tests even more demanding, complex, real-world multi-file tasks. It's scoring roughly 45.89% compared to Codex at 41.04%.
However, Codex completely dominates in Terminal Bench 2.0. That specific test measures terminal-style execution tasks and code review strengths. It proves that Codex is incredibly sharp at catching edge cases, logical errors, and security issues very quickly when reviewing isolated chunks of code.
If we connect this to the bigger picture, though, looking at token counts and benchmark percentages is only half the battle.
Right.
We have to talk about the reality of enterprise IT, and that reality is that bringing autonomous agents with file system access into a corporate network is terrifying from a security perspective.
It absolutely is. I cannot stress this enough. These aren't just chatbots answering questions in a browser window.
Yeah.
These agents can execute shell commands. They can modify code autonomously. They can open pull requests and propose changes to your core product. The research we're looking at points out that the shadow adoption of AI coding tools is a massive enterprise risk right now.
Shadow adoption meaning developers just secretly using tools without telling IT.
Exactly. Developers are just plugging these tools in because they make them significantly faster and their lives easier. But in doing so, they are completely bypassing IT security protocols.
This is something we at Kanerika see constantly. The governance gap is huge. When our team talks to enterprise leaders, their biggest panic isn't about which model gets a higher score on a GitHub benchmark. It's about what controls are already in place.
Exactly.
They are asking, can this AI accidentally commit a hard-coded database password? Can it bypass our strict compliance checks?
That is the exact problem the industry has to solve, and it is why we at Kanerika focus so heavily on delivering agentic AI solutions that are governance first. We realized early on that you can't just adapt general-purpose tools, hand them terminal access, and hope for the best. Right.
You have to build purpose-built agents for specific business functions with guardrails inherently built in. Instead of one massive AI doing everything, we deploy specialized agents. For example, we have Karl, which handles complex data insights. We have DokGPT for enterprise document intelligence.
Right.
We built Susan, an agent specifically designed to hunt down and redact PII, personally identifiable information like social security or credit card numbers, before they ever hit a database. And we have Alan, which handles legal document summarization.
And the crucial part of how we at Kanerika deploy these agents is that they don't operate in a vacuum. They integrate right into existing enterprise data pipelines. They have role-based access controls and unalterable audit trails already baked in.
Built in from the start.
Exactly. We build these systems adhering to ISO certifications like ISO 27001 for information security management, as well as IPA for healthcare data and SOC 2 compliance right from day one. It is not a retrofit. It is built securely into the architecture.
Because if you have to retrofit governance onto an AI agent that already has terminal access, you are adding months to your deployment timeline and introducing massive security vulnerabilities.
It has to be secure by design.
But let's step away from the governance side for a moment and look at how these tools actually behave when you set them loose on a long, complex coding task. This brings us to a fascinating dynamic: multi-agent coherence versus pure speed.
This is where developer feedback from the trenches becomes invaluable. The pattern that surfaces repeatedly in the notes is that Codex is incredibly fast on the first pass of a task.
Okay.
But if a task requires 20 or more autonomous steps, Codex tends to lose context. Because of how it handles asynchronous parallel execution, it will sometimes start making changes that conflict with the fixes it just implemented 10 steps ago.
It's like a handyman walking into a room to fix a window, getting distracted by a crooked picture frame, fixing the frame, and then completely forgetting why they walked into the room in the first place.
It gets caught in a loop. That is a perfect analogy. It is incredibly fast, but it loses the plot. Claude Code, on the other hand, handles those long-chain tasks beautifully. And it does this primarily because of a native feature called agent teams.
How do agent teams actually work?
Imagine you are doing a massive multi-file refactor where a single change in a core component ripples through 50 different files.
Okay.
Claude doesn't try to hold it all in one single thought process. Its agent teams use a shared task list. It orchestrates subagents, assigning specific parts of the refactor to different agents so they never lose track of the interdependencies. They communicate with each other. It is a much more coherent, methodical approach for deep architectural work.
What surprised me in this material was the developer feedback on the actual personalities of these tools. It is highly relevant to how a team integrates them into their workflow.
Definitely.
Codex is consistently described as concise, defensive, and blunt. If it hits an error, it tells you exactly what went wrong and gives you the exact fix. It even proactively adds input validation that you didn't ask for, just to be safe.
It acts exactly like a no-nonsense senior developer who doesn't want to chat. They just want to push secure code and move on to the next ticket.
Exactly. And Claude Code is the complete opposite. It is incredibly thorough, and developers note it is much better at understanding vague or ambiguous prompts.
Yes.
But they also report that it can be annoyingly verbose. It might generate lengthy explanatory responses or literally create thousands of markdown files just to answer a simple architectural question.
Which is a lot.
And apparently, it has a tendency to preface its code corrections with positive affirmations, which can drive some engineers crazy when they just want the raw syntax.
It really is the difference between a tool that acts like a strict compiler and a tool that acts like a highly talkative pair programmer who wants to discuss their feelings about the code base before writing the script.
So, what does this all mean for you and your team? How do you actually choose which of these tools fits your workflow? The data gives us a fantastic breakdown to help make that decision. Let's start with who should be choosing Claude Code.
You should choose Claude Code if your team is terminal native. What that means is your developers need to be comfortable working in a command line interface, typing text commands rather than clicking buttons, and running environments like Node.js 18 or higher.
Got it.
It is the absolute right choice if you need that deep, multi-agent coordination for complex refactoring.
And obviously, as we discussed, it's the winner if you have strict data residency and compliance rules that absolutely require local execution, so your proprietary code never bounces to a cloud server.
Exactly. It's also the winner if you need to build custom agent behaviors by completely rewriting the system prompt. That is a capability Codex actually blocks by verifying the system prompt hash on the back end, meaning Codex forces you to play by its rules.
Okay, so if I'm a tech lead trying to decide who is Codex actually built for?
Codex is the clear winner if you have mixed teams with non-CLI developers. We are talking about quality assurance engineers, technical product managers, data analysts. Codex has a clean, accessible web user interface.
So no terminal commands required.
Right. Those team members don't have to spend 10 minutes wrestling with terminal commands, installing dependencies, and managing API keys just to use the tool.
You should also choose Codex if your primary need is raw speed. If you have fast, high-volume, repetitive tasks, like generating unit tests across hundreds of files or automating pull request reviews, Codex can just blast through those bounded issues in its own secure sandbox.
But here is the ultimate enterprise solution presented in the data. You don't necessarily have to choose just one. The most effective modern workflow is to use both, but with strictly defined roles.
Using them as a tag team.
Exactly. You deploy Codex for high-velocity feature generation, automated testing, and routine-bounded tasks. Then you bring in Claude Code for the heavy lifting, complex architectural reviews, navigating massive legacy code bases, and executing production-sensitive multi-file refactors. It costs a bit more in toolchain management, but it extracts the absolute best strengths from both models.
But, and this is a massive but, the material issues a critical security warning that you cannot ignore, regardless of whether you use the tag team approach or just pick one.
Yes, this is huge.
Neither Codex nor Claude Code comes with built-in secret or PII detection.
This raises an incredibly important point for any IT or security department. Think about it. If these autonomous agents are reading your entire local file system or repository, they will read your hard-coded API keys. They will read your database passwords. They will read your user data if it happens to be sitting in a local testing file.
So what is the safeguard?
You absolutely must pre-scan your code bases with security tools like TruffleHog or Git Secrets before letting these agents loose. These are specialized scanners that hunt down accidental passwords and keys in your code. You have to confirm all credentials are securely stored in environment variables or a dedicated secrets manager. If you skip this step, you are practically asking for a massive security breach.
To bring all of this formal analysis to life, let's look at some real-world impact case studies. Because adopting the right AI framework, governed correctly, completely transforms the bottom line. This isn't just theory for us. Let's talk about a couple of massive successes we at Kanerika have achieved recently using these governed agentic AI frameworks.
Let's look at a major player in luxury retail. Before we stepped in, they were struggling with highly inconsistent pricing across different global regions. Their manual repricing strategy was so painfully slow that they were constantly leaking revenue. They simply couldn't respond to competitor moves or demand shifts fast enough.
And we didn't just throw a generic language model at the problem. We at Kanerika implemented an AI dynamic pricing engine using Karl, our specialized data insights agent, combined with our FLAP analytics platform to ensure strict governance.
Right.
The AI digested millions of data points, real-time demand signals, competitor pricing, customer lifetime value. It then optimized pricing autonomously across all their SKUs, their individual products.
The impact was immediate and measurable. We saw a 24% increase in profit margins on their top SKUs and a 39% faster price change cycle. Plus, because of the governance frameworks, every single pricing decision was completely auditable. That is real, tangible money hitting the bottom line.
The second case study we should look at is just as impressive. This involved a fashion house dealing with seasonal and capsule collections. Forecasting demand for the fashion industry is notoriously difficult because trends change overnight.
Totally unpredictable.
Right. Relying on human intuition and old spreadsheets was leading to massive overstock, which meant devastating end-of-season markdowns. Or conversely, they were completely stocking out of popular items and leaving money on the table.
So our team deployed machine learning models that ingested historical sales, macroeconomic signals, and even unstructured data like influencer trends and social media mentions using our FLPI platform.
Right.
Then, using our KRL agent for agile forecasting, the different global teams could align their production schedules based on real-time data insights rather than guesswork.
The results were staggering. An 87% improvement in forecast accuracy, 22% fewer stockouts during peak season, and a massive 37% reduction in inventory holding costs. They stopped paying to store clothes nobody wanted to buy.
Those numbers prove exactly why we're having this conversation today. When you synthesize the final takeaway from all this material, it becomes abundantly clear. The workflow harness and the governance matter far more than the underlying AI model you choose.
Absolutely.
Whether you decide to build your infrastructure around Opus 4.6 or GPT 5.3 Codex, the true differentiators in the enterprise are the quality of your prompt engineering, how securely you configure your environments, and how clearly you define the roles of these autonomous agents within your existing human teams.
I completely agree. The tech is incredible, but the execution is everything, and it leaves you with something huge to think about. If these AI coding agents are already coordinating multi-file refactors, executing shell commands autonomously in the terminal, and achieving over 45% success rates on real-world, senior-level software engineering tickets, it's wild. What exactly does the job of a developer look like 5 years from now? Will coding become less about writing syntax line by line and entirely about managing teams of specialized AI agents to execute your grand architectural vision? It is a wild frontier. Thank you so much for joining us on The Digital Shift, and we highly encourage you to keep exploring the future of enterprise AI.